All right, what's up, everybody? So we are now moving on to 7.3. Now, 7.3 and 7.4 are going to be pretty short videos because they're all about shortcuts to proving similarity, right? So in the previous video, we looked at figures are similar based off of if corresponding angles are congruent and all of the corresponding side ratios are equal. Okay, so now we're jumping into specifically similar triangles. So back to triangles for a little bit. It won't be too much longer, even though Unit 8 is still triangles as well. Okay, so let's do a quick stroll down memory lane and try to remember the shortcuts for proving congruent triangles. So remember, we didn't have to show that every single piece was congruent. We only had to show specific things. So those shortcuts were side, 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 angle, angle, side, angle, 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 side, and HL, or hypotenuse leg, and that one only worked for right triangles. So remember, those were the shortcuts that allowed us to say that two triangles were congruent without having to find every single piece of information. So with similarity, there's also shortcuts, and today we're going to cover angle, angle. Okay, so here's two triangles. Triangle ABC and triangle DEF, and I'm going to tell you that angle A congruent to angle D and angle C is congruent to angle F. Now remember that two figures are similar if corresponding angles are congruent. And now with a triangle, we only have three pairs of angles, and the key to this one is knowing that all three angles of a triangle have to add up to how much? 180. So our third angle theorem states, if two pairs of angles are congruent in two triangles, then the third pair of angles has to be congruent. Has to be, because they have to add to 180. So if two of the three are the same, then the third pair has to be the same. So we only technically need to know that two angles are congruent. Okay. So based off that information, triangle ABC is similar to DEF via angle, angle. Okay. Now remember that the corresponding order still matters. So I can't put ABC similar to EDF. It has to be in that corresponding congruent order for the angles. Okay. So if I'm looking at this one right here, okay, on the left-hand side, remember that if we know two angles, we can always find the third. So 180 minus 57 minus 48, that allows me to then say that this angle is 75. So I can say triangle JKL is similar to triangle. Now J is 48, which means Q is 48. If I say, and then K is 75, P is 75, so I would say P next, and then M. Okay. Now, the next diagram, this is where a lot of our previous knowledge is going to come into play. So notice you have two triangles. Okay. And then we also know that these two sides are parallel in our diagram. So take a second to think, can you spot some congruent angles? So the first pair I can spot is right here, vertical. The next pair you can spot is right here, and that is because of alternate interior angles. Parallel line, transversal. So you also could have said that this angle and this angle are congruent because of alternate interior. Okay. So if I want to make my similarity statement now, I can say triangle SRT is similar to triangle S. Now S is a reflexive angle. Okay, it's the same angle being used in both. So I would start both of them with S. And then R corresponds to W, and then T, So yeah, S and W, and then X corresponds, oh my goodness, I completely messed this up, my fault. It should be triangle SRX is similar to triangle SWT. I apologize, guys. I used the R from the left and the T from the right. There's it. That's correct, though. SRX is similar to SWT. Okay? And so you technically can put the first one in any order you want, but the second one has to match up. And most of the time I'm going to give you the name of the first one, and you're going to have to match the second one to the corresponding order. Okay, let's look at this one. So again, the goal of all of these guys is going to be able to create similarity statements. So now in this diagram, you have a triangle inside of a triangle. Is there an angle that is the same for both triangles? That would be angle A. So both of our triangles actually are going to start with A. That's how I would do it anyway. And let's go ahead and name the bigger one. So ACD. Now again, we have parallel lines. Now we don't have alternate interior, we now have corresponding. Okay. Here's our transversal. So those are both corresponding. So if I ACD, I would then say ABE. These angles right here would also be corresponding. So you could pick either one of those greens that we have up there. Similar concept here, right? So triangle UWZ is similar to triangle U. Both of those are right angles, XY. Okay. This one's a little tricky, okay, but again, notice that I is the angle that's being used in both. So triangle, let's say IJH is similar to triangle I. And notice I to J, J is that single arc. In our big triangle, H is the single arc. So it'd be IHK. So again, guys, there's technically two triangles here. There's triangle IJH, and then there's triangle IHK, excuse me. Okay. So if we are able to prove similarity by angle, then corresponding ratios are equal, right? And so that was kind of the thing that we learned in the last section, that if triangles are similar, not only are corresponding angles congruent, but corresponding ratios are equal. So if we looked at this one right here, right, we know that triangle ABE is similar to triangle ACD. It's almost the exact same diagram we had. We had that reflexive angle up here, and then we have our corresponding angles here and here. But now what we're going to do is we're going to throw in some lengths. And we need to set up a ratio to be able to solve for y. Okay, now the key to doing this is finding the corresponding side ratio that has actual numeric values for both lengths. Okay, so when you're looking at the corresponding parts of your triangles, you're trying to find the scale factor first. So in this case, when I look at this, right, notice I don't know this length here, which corresponds to this one. So our parallel sides are corresponding, so I can't use the 3.5, so I'm not going to use it. This 3 in this triangle corresponds to this big side length here. I know that that's 5. So that's going to be my scale factor ratio. Then the y right here corresponds to this entire side length here. Now that side length is y plus 3. So notice, guys, I'm doing little triangle side over big triangle side. And that has to stay consistent, because if you mess that up, even though you're going to have two ratios, your answer will be wrong. So because these are similar via angle, that means that those two ratios are equal. Since they're now equal, we can cross multiply them and solve them. So 5 times y is 5y. 3 times y plus 3 is 3y plus 9. Subtract the 3y from both sides. I get 2y equals 9. So y equals 4.5. Okay. Again, we have our reflexive. So again, I know that triangle MQN is similar to triangle MPO. Okay, so then that means that 5 over 5 plus x equals 6 over 6 plus 3.6, 9.6. Cross multiply, I get 30 plus 6x equals 9.6 times 5 is 48. Subtract the 30 from both sides, 6x equals 18, so x equals 3. Eventually, guys, there's going to be a little bit of a shorter way or a little bit different way to solve this problem, but we're not going to learn that until a little bit later on, okay? Now notice, guys, that I'm creating the ratios, or I'm making the similarity statement before I actually solve it. You don't have to do that, okay? So, for example, I know that triangle QUT is similar to triangle QSR, but that's not something you really need to do. So I know that 10 corresponds to 4, and I know that 2x plus 10 corresponds to x plus 3. And again, because these triangles are similar, they're similar because we have vertical and you have alternate interior, angle, angle, that makes them now proportional. So I can cross multiply 10x plus 30 equals 8x plus 40. Subtract the 8x, subtract 30, 2x equals 10, so x equals 5. All right. Good luck on the homework. Let me know if you have any questions.